Welcome to First the Future, where we explore the past, present, and future of digital engineering and PLM. In this episode, we're joined by Iver, Kjelsås, and Youssef Mejar from Revolve NTNU, the student team pushing the boundaries of electrical vehicle design and simulation, along with Björn Lundin from TECHNIA. Together, we'll uncover how collaboration, creativity, and technology all come together to shape the engineers of tomorrow. Let's dive in.
Welcome to this podcast around Future Now. Today we have our Revolve team with us. My name is Björn Lundin. I'm the Customer Success Manager in TECHNIA, Nordic and Benelux. I have a simulation background and have been working with Revolve for a time now. So together with me today, I have Youssef and Iver from Revolve. So maybe Youssef, you can start introducing yourself and your role within Revolve.
Yeah. Hello, I'm Youssef. Thank you for having me on your podcast. I will be doing applied design this year, and I did simulation on the monocoque last year.
Thank you. And Iver, what's your role at Revolve?
Yeah, thank you for having us. My name is Iver. For the 2026 season, I will be the technical leader for the mechanical department. I have a background in mechanical engineering. Previously done the cooling system and been a group leader in the team.
Thank you so much. So how did your team start working with advanced simulation and why?
And so we have always been using advanced simulation because the project has been in a very short time frame, and we have to rely on that our solutions will work when they are applied to the track. But how we have used it has changed quite a bit over the years. For earlier years, we focused a lot on how individual components are designed and the performance of individual components. And through the years, we have focused more on how each component work as a system of components and how each component contributes to the whole system. So, for instance, the stiffness of the suspension, evaluating how each single part of the suspension contributes to the total stiffness and how you can optimize the way reaching the overall system requirements.
Thank you, Iver. Youssef, you were new to the team last year. How was the learning curve like when it comes to simulation?
So the learning curve for learning any new tool, especially when it comes to advanced simulation, I think is quite high. But of course, with the help of the TECHNIA workshops, it lowered that barrier to entry. But I would still say it's a relatively high learning curve. However, once you get past the initial learning curve, it becomes easier and intuitive to use.
Makes sense. Iver, you were touching on this before about how this has evolved, but how would you say that the methods have evolved from the first car projects to now?
What I was mentioning was that we spent a lot of time optimizing, for instance, like the upright that Youssef is designing this year. So we would spend a lot of resources, maybe topology optimizing this component, but we have found that with our very limited time, that this might not be the best way to spend the time that we have. So having a simulation that we can trust at every level is more valuable than very optimized structures for single components.
And you say that the time is limited. How much time do you have to design this car?
Yeah, so there is about 2 or 3 months. We, especially after having set a concept for what you want to do with your design, what changes you want to make, and implementing those concepts are from about October to December. So, and then the manufacturing starts in January and assembly.
Wow. Okay, another limited factor might be budget. How would you say that simulation supports the quite limited budget you have?
For us, for most systems, we only have a single part. So for the uprights, the front wing, rear wing, the single part that we are going to manufacture will have to be the one that we are using at competition for the most part, especially with wanting to have the best performing part as possible. It's really important that it performs like we expect. That's why we spend time with the simulation so that we can be certain that it performs how we expect. And we don't have the time for instance, making a prototype and testing it and seeing we don't have the budget or the time, so it has to work on the first try every time.
Thank you, Iver. Youssef, how would you say that the collaboration shape innovation in your team?
So the car we have is essentially a system of systems, and so when every person on the team is responsible for their own system, they're also aware that their system doesn't exist in a vacuum, and that every design decision they have affects people in the neighboring systems or the interfacing systems they have. And so that's when collaboration between different team members is essential to achieve the overall system goals that have been set. A clear example of this is the compliance chain for the suspension system. For example, you have a lot of collaboration between the uprights responsible, the outboard suspension design responsible, the inboard suspension design responsible, the chassis design as well. And since it's a tight balancing act of compliance, collaboration between all of these people is extremely important.
Okay, Youssef, you say you collaborate within the team. Do you also collaborate with all team members? Maybe this is a question for you, Iver. How do you collaborate with all team members?
We have both members or existing team members from last year's team within the team this year, and we have external members as well we try to involve as much as we can, try to have discussions and try to get technical insights from people that now work in industry, work in Formula One, and come into our reviews with things that they have learned from their time here in Revolve and their time out in the industry, and trying to help the team make the best car possible. And more for like the collaboration that you asked about previously. One example I really liked from moving from the 2024 to the 2025 season was torsional stiffness tests and targets that were set for the 2025 team, where the suspension group and the chassis group specifically worked together on a test where they could break down the torsional stiffness into the chassis and suspension and the components of the suspension, so that we could, since this is the torsional stiffness is dependent on the suspension, the front suspension, the rear suspension, and the chassis. And then we were able to pinpoint individual components within the suspension that we wanted to focus on. Youssef might be able to go into more detail on the chassis, where we changed it a bit to improve the aerodynamics that lowered the torsional stiffness, and we had to do reinforcements. And since it's many systems, you have to see how each system contributes to the total and how you will improve every component to reach your overall goals.
Makes totally sense. Very impressive that all team members traveling from around the world to help out with the new car. That really tells how much Revolve means to those persons. Youssef, I've met you a few weeks ago, and I sure remember that you were really eager to learn new technologies. Can you tell me a bit about what future trends or simulation technologies excite you most?
I think the integration of both design and simulation in one package is something that really excites me. And the streamlining of this iterative design process, where you go back and forth between designing and simulating and having a simulation-driven design, is something I find really exciting.
So ModSim, really?
Yes.
Yeah. Okay, a question for you, Iver. How do you see digital engineering shaping motorsports and education?
Yeah, both for motorsports, education, and in commercial settings, it's always a bit of competition. Either you're competing against another team, another person for getting a job, for instance. So being able to solve the task in the fastest and most efficient way possible will always be valued. Having, especially as digital engineering becomes more powerful, being able to utilize that better than our competitors will give us an advantage, both for us as a team, for individuals, and in future as well.
How would you say that you support future engineers with Revolve?
Yeah, we want to give students at NTNU an opportunity to both push themselves and learn, where we are a team that want to do very well, or we have goals to be among the very best teams within the world. And to do that, you have to a lot of time, but you get a lot of learning in return, and you get to be a part of a big community of people that want to learn and push each other to both new heights for individuals and the team.
And Iver, would you have any advice for other young engineers other than joining Revolve?
The advice would probably be to find something that you're passionate about, whether that be Revolve or any other project that you have for yourself, or join other students. But try to find something that you're passionate about, and that would make it a lot easier to learn, and try to get experience with a lot of different things from, if you think you want to learn simulation, try to push your boundaries a bit, try to see what else exists out there, and try to challenge yourself. There might be something else that you find interesting, or something that can contribute to how you do your work.
Passion is very important, according to you, Iver. What about you, Youssef? Any advice or any reflections you want to share with other young engineers?
I think as someone who's joined such a technical organization quite late in my studies, I would recommend that you join in early, even if you think that you might lack the technical knowledge required of such a position. Don't let that hold you back. If you find something that you're interested in, just join, and knowledge you will gain the knowledge along the way. And my other piece of advice is that find something where you can apply the theoretical knowledge you get through your education, because that's the fun part of learning, I think, is just applying the knowledge you gain through your classes. And that's essentially what for example, Revolve is.
Sounds good. So be brave and have passion, right? Okay, so that's it. Thank you so much for joining this podcast, both Iver and Youssef, and best of luck with the car for next year. You will do great.
Thank you.
Thank you very much, and thank you for having us.
Thank you so much.
Wow. That was First the Future, the TECHNIA podcast series, and our episode on the story of Revolve NTNU, a student team in Norway pushing the boundaries of electric vehicle design. A big thank you to Iver, Youssef, and Björn for sharing their journey and insights from the Revolve NTNU project and the collaboration within the team. To learn more about how TECHNIA supports the next generation of engineers through advanced simulation and design tools, visit technia.com or follow us on LinkedIn. Thank you for listening, and until next time, keep imagining, creating, and engineering the future.